System testing is a critical phase in software development. It focuses on evaluating the complete and integrated system. This testing ensures that the software meets specified requirements. It's a holistic approach that validates the software's functionality, performance, and security. System testing is essential for delivering a high-quality product. It helps mitigate risks and ensures customer satisfaction. Software development is an intricate process. It involves numerous components working together. System testing examines these interactions to identify potential issues. These issues might not be apparent when testing individual modules. By simulating real-world scenarios, system testing uncovers hidden defects. It ensures that the software functions seamlessly as a whole. System testing is not just about finding bugs, it's about building confidence in the software. A robust system testing process demonstrates the software's reliability. This builds trust with stakeholders. They can be assured that the software meets their expectations. Ultimately, system testing contributes to a successful software release. System testing aims to validate the software system as a whole. It ensures that all components integrate and work harmoniously. This process focuses on verifying if the system meets the specified requirements. It also aims to ensure the system is robust, reliable, and performs under different conditions. A primary objective is to identify any deviations from the expected behavior. These deviations could be bugs, errors, or inconsistencies. By detecting these issues early on, system testing helps reduce the cost of fixing them later in the development lifecycle. This proactive approach ensures a smoother deployment and a more stable software product. Furthermore, system testing aims to assess the system's non-functional aspects. This includes performance, security, usability, and compatibility. By evaluating these aspects, system testing ensures that the software is not only functional, but also user-friendly, secure, and performs optimally under various conditions. System testing encompasses a broad scope within the software development lifecycle. It goes beyond merely testing individual units or components. Instead, it focuses on the interaction between these components when integrated as a complete system. This holistic approach ensures that the software functions seamlessly as a whole. The scope of system testing extends to both functional and non-functional aspects of the software. Functional testing verifies that the system performs its intended functions correctly, meeting the specified requirements. This includes testing various features, inputs, and outputs to ensure they align with the expected behavior. On the other hand, non-functional testing evaluates the system's performance, security, usability, and other quality attributes. This involves testing how well the system handles different loads, its resilience to security threats, its ease of use, and its compatibility with different environments. System testing employs various methods to thoroughly evaluate the software. Each type focuses on specific aspects of the system, ensuring comprehensive coverage and high-quality software delivery. Understanding these different types is crucial for tailoring the testing process to the specific needs of the project. Functional testing. This type verifies that the system performs its intended functions correctly. It involves testing various features, inputs, and outputs, ensuring they align with the specified requirements. This includes testing user interfaces, APIs, data handling, and business processes. Performance testing. This type evaluates the system's performance under different load conditions. It assesses the system's responsiveness, stability, and scalability. This helps identify bottlenecks and optimize the system for optimal performance. Security testing. This type focuses on identifying vulnerabilities in the system that could be exploited by malicious actors. It involves testing various security aspects, such as authentication, authorization, data encryption, and vulnerability to attacks. Usability testing. This type evaluates the system's ease of use and user-friendliness. It involves real users testing the system and providing feedback on their experience. This helps identify areas for improvement in the user interface, navigation, and overall user experience. Regression testing. This type ensures that changes made to the system, such as bug fixes or new features, have not introduced new defects. It involves rerunning previously executed test cases to ensure the system's stability after modifications. System testing follows a structured process to ensure thoroughness and effectiveness. This process typically involves several key steps. First, test planning. This initial step defines the scope, objectives, and approach for system testing. It involves identifying the testing environment, resources, and timelines. A well-defined test plan is crucial for guiding the entire testing process. Next, test environment setup. This step involves creating a dedicated environment that closely resembles the production environment. This ensures that the testing results accurately reflect the system's behavior in a real-world setting. Moving on to test case design and execution. This step involves designing test cases that cover various aspects of the system, including functionality, performance, security, and usability. These test cases are then executed to identify any deviations from the expected behavior. Lastly, defect management. As defects are identified during testing, they need to be documented, tracked, and resolved. This involves reporting the defects, prioritizing them based on severity, and assigning them to developers for fixing. Creating a realistic test environment is crucial for effective system testing. This environment should mirror the production environment as closely as possible, including hardware, software, network configurations, and data. A dedicated test environment minimizes the risk of unexpected issues arising from differences between the testing and production environments. When setting up the test environment, it's essential to consider factors like operating systems, databases, web servers, and third-party integrations. These components should be configured to match the production environment's specifications. This ensures that the testing results accurately reflect the system's behavior in a real-world setting. Data plays a crucial role in system testing. Using realistic test data is essential for simulating real-world scenarios. This data should be representative of the data that the system will handle in production. This might involve using production data or creating synthetic data that closely resembles the real data. Test case design is a critical aspect of system testing. Effective test cases ensure comprehensive coverage of the system's functionality and non-functional aspects. These test cases should be designed to validate the system's behavior against the specified requirements. When designing test cases, it's important to consider various scenarios, including normal cases, edge cases, and error conditions. This helps identify potential issues that might not be apparent under normal circumstances. Each test case should have a clear objective, input values, expected output, and a pass-fail criterion. Once the test cases are designed, they need to be executed systematically. This involves setting up the test environment, running the test cases, and recording the results. Test execution can be done manually or using automated testing tools. Automated testing can significantly speed up the testing process and improve efficiency. Defect management is an integral part of the system testing process. It involves identifying, documenting, tracking, and resolving defects found during testing. Effective defect management ensures that issues are addressed promptly and systematically, leading to a higher quality software product. When a defect is identified, it needs to be documented thoroughly. This includes providing a clear description of the defect, the steps to reproduce it, the expected behavior, and the actual behavior. Screenshots or videos can be helpful in illustrating the defect. Once a defect is documented, it needs to be tracked throughout its lifecycle. This involves assigning a unique ID to the defect, prioritizing it based on severity, and assigning it to the appropriate developer for fixing. The defect's status should be updated regularly to reflect its progress. After a defect is fixed, it needs to be retested to ensure that the fix has addressed the issue without introducing new problems. This process of retesting is called regression testing. Effective defect management ensures that all identified defects are addressed and the software is free from critical bugs. Effective system testing offers numerous benefits throughout the software development lifecycle. It's an investment that yields significant returns in terms of software quality, reduced risks, and increased customer satisfaction. One primary benefit is the early detection and resolution of defects. By identifying and addressing issues early on, system testing helps reduce the cost and effort required to fix them later in the development cycle. This proactive approach saves time, resources, and prevents potential delays in software releases. Moreover, System testing ensures that the software meets the specified requirements and functions as intended. This validation provides stakeholders with confidence in the software's reliability and robustness. It minimizes the risk of unexpected behavior, errors, and system failures. Furthermore, system testing contributes to a positive user experience. By testing the software's usability, performance, and compatibility, system testing helps ensure that the final product is user-friendly, efficient, and meets users' expectations. This leads to higher user satisfaction and increased adoption rates. System testing is an indispensable phase in the software development lifecycle. It plays a crucial role in ensuring the delivery of high-quality, reliable, and user-friendly software. By thoroughly evaluating the integrated system, system testing identifies and mitigates potential issues before they reach the end users. Through a structured process of test planning, environment setup, test case design and execution, and defect management, system testing provides a comprehensive assessment of the software's functionality, performance, security, and usability. This rigorous testing process helps ensure that the software meets the specified requirements and performs optimally under various conditions. Investing in robust system testing practices yields significant benefits. It reduces development costs by identifying defects early on, minimizes risks associated with software failures, and enhances customer satisfaction by delivering a high-quality product. By embracing system testing as an integral part of the software development process, organizations can deliver software that meets and exceeds expectations.